this left null space. Okay, I'll do it the example. As always, not that one. The left null space is not jumping out at me here. I know which are the free variables, the special solutions, but those are special solutions to AX equals 0, and now I'm looking at A transpose, and I'm not seeing it here. So, but somehow you feel that the work that you did, which simplified A to R, should have revealed the left null space too. And it's slightly less immediate, but it's there. So from A to R, I took some steps, and I guess I'm interested in what were those steps, or what were all of them together. I'm not interested in what particular ones they were. I'm interested in what was the whole matrix that took me from A to R. How would you find that? Do you remember Gauss Jordan, where you tack on the identity matrix? Let's do that again. So I'll do it above here. So this is now the idea of, I take the matrix A, which is m by n. In Gauss Jordan, when we saw him before, A was a square invertible matrix, and we were finding its inverse. Now the matrix isn't square. It's probably rectangular. But I'll still tack on the identity matrix, and of course, since these have length m, it better be m by m. And now I'll do the reduced row echelon form of this matrix. And what do I get? The reduced row echelon form starts with these columns, starts with the first columns, works like mad, and produces R. Of course, still that same size, m by n, and we did it before. And then, whatever it did to get R, something else is going to show up here. Let me call it E, m by m. It's whatever, do you see that E is just going to contain a record of what we did? We did whatever it took to get A to become R. And at the same time, we were doing it to the identity matrix. So we started with the identity matrix, we buzzed along. So we took all this row reduction amounted to multiplying on the left by some matrix, some series of elementary matrices that all together gave us one matrix, and that matrix is E. So all this row reduction stuff amounted to multiplying by E. How do I know that? It certainly amounted to multiplying by something, and that something took I to E, so that something was E. So now look at the first part. E, A is R. No big deal. All I've said is that the row reduction steps that we all know well, taking A to R, are in some matrix, and I can find out what that matrix is by just tacking I on and seeing what comes out. What comes out is E. Let's just review